This is lesson 57, which is about adding expressions with negative exponents. So we can see this is an example of an expression with a negative exponent, a couple negative exponents actually. And so we want to add these. And right now, looking at them, they don't look like terms because they're not. But the first thing I want to do is rewrite them with positive exponents. So we know that x to the negative 1 means that the x needs to go on the bottom, and then it becomes x to the positive 1. And then y to the negative 1 is just simply 1 over y. And we've also learned how to add these types of rational expressions. We need to get a common denominator. So the least common multiple of x and y would be xy. So if I want my new denominator to be xy, what do I need to multiply ax by? I need to multiply x by y, which means I also must multiply a by y. So I'm really multiplying by y over y, which is 1. That gives me ay for my new numerator here. The second one, y needs to be multiplied by x, so I must also multiply the top by x. And so then I would just get 1x, or just x. And so this is the two expressions added together in one fraction. Let's do some more examples. So for the next example, let's do a to the negative third power x times y to the negative first minus b x to the negative second. So this one's a little more complex, but we're going to do the same thing. First, we need to rewrite the expressions with positive exponents, which means the negative ones have to go into the denominator. So a to the positive third now, and y, and then the x stays on top for the first one. For the second one, we just put the x squared on bottom, minus b over x squared. And now looking at these two denominators, the least common denominator would be a cubed times y times x squared. Basically just multiplying the two denominators together, right? So that means that the first fraction must be multiplied by x squared on the top and on the bottom. So that would give me x squared times x is x to the third. I'll just go ahead and write that in red. And then the second one needs to be multiplied by the other denominator, by a cubed y. A cubed y. And then that would give me minus b times this. So I can write it in alphabetical order, a cubed times b times y. And now it's all consolidated into one fraction. Let's do a couple more examples. In these ones, you can pause the video and try them on your own and then check the answer. So, example 3. Let's do a to the negative second power times x times y to the negative first plus a times z to the negative first. So go ahead and pause the video and give it a try. So checking the answer for example 3. First you turn them into fractions with positive exponents, and then we multiply each of the fractions by the opposite denominator to get a common denominator. And then we just simplify and consolidate it into one fractional expression. All right, let's just do one more example. Again, you can do this one on your own and pause it to check your answer. This would be example 4. Okay. we have x to the negative fourth y, z to the negative second, plus 2x y to the negative first, and z to the negative third. So again, first thing we should do, make all the exponents positive, find a common denominator, and then simplify. So go ahead and pause it and try it on your own. So checking the example 4, this one is a little bit tricky because the least common multiple of these two denominators is actually x to the fourth y z cubed. And so for this first one, in order to get that denominator, I would have to multiply it by y and just by 1z. So I would do the same at the top, which would give me a new numerator of y squared z. And for the second one, in order to get to the least common denominator, I had to multiply the top and bottom by x to the fourth. So then I have 2x to the fifth as my new numerator, and that's my answer.